Hey guys, welcome to the second day of quadratic functions. Yesterday we introduced you to what a quadratic function is. It's an equation with an x squared in it. We looked at the graph known as a parabola, and you see that word up here um, in our aim for today. And we also talked about what an axis of symmetry is, and talked about a turning point. Turning point is sometimes called the vertex. And it can be a minimum or maximum point. Talked about all those things yesterday. Today we're going to take the next step and actually figuring out what the axis of symmetry is, not by looking at the graph, but actually by exploring the equation and what's the connection between the equation and the axis of symmetry. Okay, so let me get rid of the video so you don't have to look at me. And let's get right into today's stuff. So let me clear out the drawing. Sorry. Okay. So yesterday we looked at the graph of a quadratic. Here's the graph of this particular quadratic, x squared minus 6x plus 8. It's got that patent sort of U shape to it that you see is symmetrical, of course. There's the table for it, which has those repeating values that we have discussed. You know, there's 8 and 8, 3 and 3, 0 and 0. That's what gives it this symmetrical look to it. Now, yesterday we identified that the axis of symmetry would be that line that sort of cuts that parabola in half, and the turning point is that point at which the graph changes. Now, one thing you should notice is that the axis of symmetry always goes through the turning point. That's kind of critical. They do go hand in hand with one another. Okay. All right, now let's look at really what our focus is of today. That's more of a recap of what we did yesterday. Our goal today will be to take that equation that we just saw, y equals x squared minus 6x plus 8. I just rewrote it over here. And find the axis of symmetry by hand. Now, you can do that without the graph using this formula here. So in this box, I have a formula. It says x is equal to negative b over 2a. It's the formula for the axis of symmetry. It'll tell you the equation of the axis of symmetry. Now, where do I get my values for a and b? Well, if you remember from the first thing that we talked about yesterday, the a value is the value that's in front of the x squared. So in this case, that a value is 1. So that's why I have a 1 in here for a. Okay, our b value, let me use a different color here. I'll use maybe pink or something. Our b value is the value that's in front of the x term. So in this case, negative 6. Now notice, since the equation is negative b, I have to put in negative 6. That's a little bit tricky. Okay, negative 6 is positive 6. Like you have two negatives there, it makes it a positive. 2 times 1 is 2. 6 divided by 2 is 3. So I find out the axis of symmetry is x is equal to 3. Now, what does that mean? That means that it's a straight line that goes through 3 on the x-axis. So if I go back to what my picture looked like in the last screen, you're going to see, take a look, the axis of symmetry is that line that goes through x is equal to 3. Now, we could see that visually if somebody graphed it, but now we know how you can find it simply by having the equation. Now, I also see that it looks like in this case, the turning point is 3, negative 1. So believe it or not, since we knew the axis of symmetry was 3, we could get that turning point as well. And actually, why don't I walk you through doing that real quick? If I know that the axis of symmetry is 3, I can just take that axis of symmetry and substitute it right back in, and I'm just kind of skipping through this stuff, right back into the equation that we had. Okay, that equation was, hold on, let me just get my pen here. The equation was y equals x squared minus 6x plus 8, Well, watch what happens when I substitute 3 back into this equation for x. 3 squared minus 6 times 3 plus 8. Now, that's supposed to be parentheses. I'm running out of room here. All right, 9 minus 18 plus 8. 9 minus 18 is negative 9, plus 8 is negative 1. So now my y value is negative 1, and that's how I got my turning point of 3, negative 1. I just substituted the x value from my axis symmetry back into the equation and found that it was 3, negative 1. I can also just take my calculator. Check this out. If I have my graphing calculator, I can just type in that equation, y equals x squared minus, let me just type it in, 6x plus 8. Now we already know what the graph looks like, but let's just look at it again. Now if I want to get, let's go, it's a little slow. All right, if I want to get the turning point, one thing I can do is just hit second table, and I can go where x is equal to 3, and I can see right up there. I don't know if I can highlight it. I'll go down to it. 3, negative 1. So there's my my turning point that way as well. So as long as I know my axis symmetry, I can find the turning point in the table of the graphing calculator. So there you have it. Okay. Let's look at one together, and then we'll do it both on the calculator and by hand. All right, we're not going to do both of these. We'll do the top one. Let me erase my work here. Okay, so it says find the axis of symmetry and find the turning point. So we'll do the top one. So the axis of symmetry is the formula x equals negative b over 2a. So my a value in this case is 1 again. My b value is, in this case, is 8. So I'm going to put in negative 8 up here because it's negative b over 2a. I'm going to fall down into here. Negative 8 over 2, which is negative 4. So the axis of symmetry is x is equal to negative 4. That's the axis of symmetry. So if somebody asked, I could write that down. That's the axis of symmetry. Okay, now to get the turning point, I'll do it in a different color here. I take my axis of symmetry I got, negative 4, and I put it right back into the equation, y equals x squared plus 8x plus 4. So I'll put in negative 4 wherever I see an x. Now, I make sure I put it in parentheses, because if I don't, the calculator will give me a wrong answer there, so just be careful. Making sure you can see everything. Okay, negative 4 squared is 16. 8 times negative 4 is negative 32 plus 4. So this is going to come out to be, I think, negative 12. So then that makes my turning point a combination of those two things. Negative 4, negative 12. I use my axis of symmetry's value for x, and I use the y value I got, and that's my turning point. Now let's just confirm that with our calculator. So I'm going to go back to my calculator, and I'm going to hit y equal to, the equation this time is x squared plus 8x plus 4. Okay. I can look at the graph if I want to look at the graph. I don't really need to, but there it is. I can see the turning point is not even shown on the screen there, so it makes me feel like negative 4, negative 12 is probably it, because I know this graph, the screen only goes down to negative 10. But let me look at the table. At negative 4, yep, negative 12. We got it. So negative 4, negative 12 is our turning point. All right. Well, that's it for today. That was finding the axis symmetry by hand and finding the turning point by hand with a little assistance to check using the graphing calculator. Going to get a chance to practice this on your homework tonight, and then we'll do some more work with the graphing calculator tomorrow. All right.